Hello, and welcome to Control F, the NSI's Cyber and Tech Center's podcast that features season long groupings of issues at the intersection of technology and national security. Our first season of Control F is an 8-episode series focused on game changing technologies. These episodes are released every other week over the course of 4 months and take a deep dive into key emerging technologies that are reshaping our world and the ever evolving tech policy landscape alongside them. During each episode this season of Control F, we're featuring a leading technical expert in a game-changing area of technology, as well as a key investor funding the practical application of these technologies. Today, on our final episode of the season, we'll discuss how the advent of generative and other rapidly evolving forms of AI combine with ongoing trends in cloud and edge computing, and how it's transforming how we interact with and process large amounts of data, and the potential this combination has to deliver massive new opportunities in innovation and even further transform the role that AI plays in our everyday lives. In particular, the combination of pushing AI processing to the edge, including on devices, as well as the back-end processing of even more massive workloads in the cloud, will also have significant benefits for enterprises, governments, and our warfighters in the field. Device and edge AI often processes locally, closer to the source, enabling faster responses and reducing latency, while cloud AI processes in remote servers, offering greater computational power and storage capacity. The choice between these two approaches, both of which are critical to taking advantage of the AI revolution, depends on factors like speed, scalability, and security. Unlike cloud AI, which often relies heavily on centralized networks, device edge AI can operate on decentralized networks, making it more adaptable for real-time applications like autonomous systems or IoT devices. Both approaches come with their own security challenges as well, as data processed at the edge might be more vulnerable to local attacks, while cloud-based systems can face larger-scale breaches. So, with significant implications for both industry and government, including national security, the question of how and why to deploy and where to deploy each approach will certainly continue to shape the future of technology development. So I'm joined today by two fantastic experts in the field to help unpack these and other issues and how we ought to think about device and edge AI on one hand, as well as cloud capabilities on the other. We'll also explore the implications of these approaches in the context of the growing threat for both criminal and nation-state actors in the cyber domain. So first with me is Dr. Durga Malladi. He's the Senior Vice President and General Manager for Technology Planning and Edge Solutions at Qualcomm Technologies, where he's been since joining as a senior engineer in 1998, the same year I graduated from UCLA. He's a UCLA graduate as well. Since 2023, Dr. Malladi has overseen technology, product management, and roadmap planning across various sectors, including AI, connectivity, processors, multimedia, cellular infrastructure, and data management platforms. He led wireless research in the 4G and 5G areas, as well as a focus on mobile broadband, ultra-reliable, low-latency comms, and massive IoT. He's a senior member of IEEE, and he holds 500-plus U.S. patents and received Qualcomm's Excellence in IP Award, the Distinguished Contributor Award, and Distinguished Alumni Award from ITT Madras. Dr. Malladi serves on the CTIA Board of Directors and the AI Governance Alliance Steering Committee at the World Economic Forum, also known as the people that host Davos. Dr. Malladi holds a B.Tech from ITT Madras and an MS and a PhD from UCLA, go Bruins, and an AI graduate certificate from Stanford. Not to be outdone, we're also joined by Guy Filippelli, who founded Squadra Ventures in 2019 to create the world-class venture fund he wished he had when he was raising capital for his startups. Previously, Guy was the founder and CEO of Red Owl Analytics, a cybersecurity startup acquired by ForcePoint in 2017, and Barrico Technologies, a consulting firm acquired by Novetta in 2018. Guy began his career as a U.S. Army intelligence officer and has served in various locations, including Korea, Italy, Germany, and Afghanistan, as well as at the NSA, which is where Guy and I met nearly 2 decades ago. He won't tell you this, but Guy actually helped lead the effort to build one of the most successful counterterrorism tools ever deployed by the U.S. government. Guy holds a BS in economics from West Point and both a BA and MA in philosophy, politics, and economics from Oxford, where he was a Marshall Scholar. Guy is currently the chairman of the board of the Commit Foundation, focused on veteran transitions out of the military, and serves on the board of the National Cryptologic Foundation. All right, guys, let's get started. So Dr. Malladi, let's set the stage for our discussion, talking about exactly how device and edge AI work, as well as cloud AI. So how they're playing a role in the AI revolution, why does it matter where and how you deploy AI capabilities?
All right, so I'll get started with where we are, state of the art in terms of how we see AI processing. The cloud is a place where there's a lot of AI, generative AI specifically, training that occurs, large amounts of data, extremely large models that can be trained over there, small and large models, tons of data ingestion, and then going with it. By the way, these days when we talk of data, it's not just about text. It's a combination of text and voice and images and video as we kind of move forwards. At the same time, on the devices, and when I say devices, this includes smartphones and PCs,
Right.
consumer and industrial IoT spaces. These devices have extremely sophisticated processors now that can run generative AI inference. In other words, once a model is trained, you actually bring it to the device and do a lot of AI personalization on top of it,
Hmm.
which means that you take into account the local context and provide responses to the end user, which makes sense to them as opposed to some generic response that comes in out there. So, bottom line, you see these twin roles. Cloud has its role in terms of training and maybe taking up inference once in a while, but the edge
Right.
devices are the ones which actually are going to be moving forwards, doing most of the generative AI inference. And somewhere in between, you can do a mix and match of both, and that's where hybrid AI comes in.
Yeah. Now, Dr. Malladi, is that true today when we're using, if I'm using ChatGPT on my phone today or Claude or Perplexity, is that happening there on my device or is it generally happening in the cloud? And are we waiting sort of in the near future that transition will happen on devices?
So if you take a premium tier smartphone today, starting from, let's take the Samsung Galaxy S24 that was launched earlier this year, back in January,
Sure.
that has the capability of running very large language models, all the way from those from Meta and their
Okay.
own Samsung models and moving forward. So some of these large models can actually run on devices today. And if you take a look at most of the PCs that were launched in the summer, there was a massive push towards what are called as AI PCs. AI PCs, you run all these models directly on device. And you
Hmm.
look at a combination of somewhere from 1 to 30 billion parameter models, which are like pretty large if you think about it. And
Yeah.
they can do all kinds of use cases just using these kinds of models.
Got it. So if I'm buying one of these AI laptops, these AI PCs, they're actually running locally all those models right now.
That's correct. You can actually
Interesting.
run that. Now, here's a way to think about it. So think about how you
Yeah.
use a PC today. With these models, you can do things like document translation. You have an email, you want to convert that into a presentation, or you have a presentation and you want to convert that into maybe some meeting notes, and so on and so forth. These things can be done. In addition to that, you can be getting work done if things run directly on device. Maybe you're on a flight and you want to get some work done. You don't necessarily need connectivity to the cloud. You don't
Mm,
scale back to the old school way of doing things. You stick to exactly this new way of productivity tools that come in with AI PCs and actually run with that. So
right.
that's where actually the benefits of on-device AI come in.
Yeah, I mean that sounds pretty powerful. So, Guy, obviously, I'd love to talk to you about the national security context because think about all the places our military. You've been to some of these places, deploys around the world where you don't necessarily have stable long-term access to the internet, right? I can imagine having on-device AI can be really powerful. But let's just talk about this from a larger scale business and corporate perspective first. So, as a venture capitalist and a former startup executive and a senior national security professional, how do you think about the business and implementation considerations of this whole debate? Cloud AI versus device AI. It sounds to me like device AI can be real powerful. What are some of the things we should be thinking about in this space?
Well, I think one of the things that Dr. Malati talked about is you still have to make a distinction between you can run models on devices, you can run large models in the cloud, but just to be very clear, like you're not running OpenAI, ChatGPT
Locally.
on your device, even
Right.
if your device is capable, because that data is sitting in the cloud. What's interesting, there's two big weaknesses that I think come into play. One is the operational localization of real-time data. Okay, so um, it's really and I'll come back to, let's say, a soldier context in this,
Yeah.
or a cybersecurity context in this. And two is the fact that for a lot of users, the data, it's not just that the data, you have these conversations about the modes of data. And I'd be curious what Dr. Malati also thinks about this, but it's one thing to be able to feed models that have been trained and ready to accept specific modes of data into them. It's another thing when the modes change. And so, when you're in an operational context and you've got new forms of data that you want to feed into these models, uh, it's not as easy in my mind as we'd like it to be, that we could just throw large language models on edge devices and equip people with operationally ready applications that are ready to evolve real time, let's say the battlefield or the operating environment. Now, with all of that said, what are the implications for the way we look at it? We're very excited about what this will do, but we're very practical about what the impacts will be. And so what we start with when we think about investing in the space is we truly try to think first about what operational impact are we trying to have and do, so number one, so that could be reducing human burden so that we could reduce human labor. We could think about reducing human burden so we can move humans to do something else. Those are two very different patterns.
Right.
We can think about being able to augment human decision making with better knowledge and better data and better judgment. We can talk about solving problems we were never able to solve or seeing patterns we were never able to see.
Right.
All of those are very, very different different problems, and they suit themselves in our mind to very different things, and they're at different levels of maturity. So what we have tried to do is be practical as an early stage fund to not get involved in solving problems that are, frankly speaking, 5 or 10 or 15 years out, or getting involved in investment activities where there's a 10-year run before something's ever profitable. So I'm sort of a practical AI investor for what it's worth. And frankly speaking, I'm looking for problems in the space where I think that the specific application of these technologies can have an operational impact in a matter of, say, months, not years, and a reasonable amount of money can be deployed to achieve those things. And just one last thing I'll say, I'll give you an example of a couple of very interesting areas that I think are very ripe to be disruptive with AI that we are investing in right now. One is natural language on the battlefield as it pertains to soldiers' abilities to interact more efficiently with things like drones or robots. And this goes back to a theme that I like to talk about, which I call productization of the battlefield. Because if you think about the assets that are on a battlefield right now, it's essentially constrained by humans. It operates all, the military operates almost like a service company on the battlefield. And I fundamentally believe that as we enable our soldiers, for example, to be able to interact with autonomous systems and swarms of autonomous systems and do so through their voice and interact with language, there's very disruptive things that happen. Right. So that's just one example. I can get into more later of topics. And we invested in a company called Primordial Labs as a result that does exactly that. And they're very focused on delivering their capabilities at the edge because, to your point before, they cannot rely on a cloud and they have to be able to be interacting in a disconnected environment. So it's just a flavor of something. I'll start with that. I'm sure you'll take me in a bunch of directions.
So, Dr. Malladi, let's talk about a couple of the things that Guy raised, right? So, one is this question of, when you have a varied form of data that you're putting into a model, and yes, it may have been trained on one set of data, it may be really performant in that model, in that mode of data acquisition, right? If you're deploying it to an edge device, should we be concerned that as new data comes in, data in different kinds of modes, that it may not be able to grapple with it as effectively as a cloud-based model? And then separately, and so I'll ask you that question first, but then separately, I want to follow up on with you is, Guy's described an interesting, capability, which is, look, we're going to have to go out in the field. You're going to need people to deploy in remote places, and you're going to need this edge capability to interact with, autonomous devices, swarms, and the like. And in that case, it seems like edge is almost perfectly suited to that scenario. So I guess I'd like to ask you sort of about the potential downside case and then the upside case.
Sure. Yeah. So let me actually start with an observation, which is something that everyone who's following the space of AI is beginning to see this now. November of 2022 is when OpenAI launched ChatGPT. It's been only 2 years, by the way, and
Isn't that
I would
amazing?
argue. And I would argue it is something. I would argue that before that point in time, uh, a large cross section of the population knew about AI, but didn't
Right.
really know that much more about it. And between November through Christmas of 22, everyone was talking about it. I mean, everyone was like, okay, did you try this out? Did you try this out? Oh my God, the responses are amazing, and so on. It's almost as if something flipped, something changed. Now, that model, which is based upon GPT-3 as it is called, it was a pretty large model. It was 175 billion parameters, which is like a gigantic model back then. Here's some news. If you take a look at today's models, which are in the order of like 7 billion or 8 billion parameters, sub 10 billion parameters, these models outperform that model from 2 years back, which was
Mm.
significantly larger. Bottom line, much smaller models today are outperforming yesterday's large models. So there is a trend line in terms of how sophisticated some of these smaller models are.
Can you tell
Why
us
are
real
these
quick why? Can you tell us why that is?
It's a combination of things. So one of
Yeah.
them is simply the fact that the amount of training data that's being used now to train these models is much, much more compared to what it was just two
Hmm.
years back, by the way.
Yeah.
The other part is there's something known as a context length. How far do you go back and see what your next token, what your next word or everything needs to be? And that's actually gradually improved. So it's a combination of
Mm.
techniques based upon which the smaller models are becoming very sophisticated. So that's a pretty big thing.
Yep.
Why do smaller models matter if you kind of look at it that way? Well, most of these models actually fit very nicely into your smartphone, into your PC,
Mm.
into anything. And so, what it means is that the use cases that you can bring from these smaller models are going to be much richer. You don't, of course, the larger models are always going to be better, but the real question is if it's 10 times larger, do I get 10 times the performance or is it like 50% more performance? And there is an ROI equation that
Right.
you actually have to think through. So the good news is that you can now make all of these models work very efficiently on devices that you and I can use. Now, coming to one of the points that Guy mentioned, and I want to actually touch upon that. Increasingly, we're going to see this. Voice is going to be the natural UI towards all the devices that you see around us. You're
Absolutely.
going to be using just voice, send an email, fetch my notes from 2 weeks back that I had with this company. And you don't have to have a mental picture of my file structure, but you actually just get it like that. And I don't have to use your hands. Write a piece of code which does this. I think of the algorithm, actually, this code generation that's occurring. This is for software companies. It also means that you can actually simply talk to your thermostat, you can talk to your doorbell. It has implications in IoT space as well. Now, these are pretty big trend lines if you kind of think about how the use cases will come in, which actually touches upon the second point when Guy was talking about, you know, in the battlefield, people talking to drones or actually trying to use drones. It's just a natural interface. In fact, one other way of looking at this is if you think about it, for the longest period of time, humans have been learning the language of machines. You do your
Right.
programming and so on and so forth. For the first time, it's the other way around. It's
Mm.
the machines that have been learning how to learn our language, which is kind of
Right.
a very different way of thinking about it. And it also means that accessibility to a large cross section of the population, it's much easier. We made devices very complex, but we also made them harder to use. Only a small fraction of the population will even know everything that they can be done. So that's like a big trend line that's coming in.
Right.
Now, as a part of all of this, and I want to touch upon the modalities that came up. So typically, the modalities that we are talking of is voice, text, images, and video as a starting point. This is where most of the large models, or these are the multimodal models as they are called, they are trained on, and we
Right.
can actually run them very efficiently on devices already today. If there is a brand new modality that actually the AI model never saw before, well, yeah, that's going to be a problem. But I think in some sense, we're kind of trying to capture as many different modalities as possible. By the time you go into automotive, you go into things like LiDAR and radar and all these other things, other signals that also come in. But I think it's going to be a constant journey as we start bringing in more and more modalities into the mix. But at
Right.
the end of the day, I come back to one point that I made earlier, which is end users are interested in a personalized AI experience, and the local context matters, which means when I ask something, if I'm just using voice to ask a question, In fact, you might need a lot more information to appropriately answer that question. Where are you? Different sensors that you might have around you to actually provide the local context and give a more personalized AI response to it.
Right. Well, in that context, I mean, so I guess I wonder if you do need to acquire that much more context, and you're gathering it from a variety of plurality of sensors. Might you not need a model that can adapt to that level of input? And might that say, well, look, there's no doubt that over time, our chip capabilities and our processing capabilities on edge devices are going to get better. The models, to your point, are going to get smaller, more performant, maybe even more specialized, as we've talked about now, as we think about more inferential models that create new models that are smaller, more packaged up. Sort of, and also, test time compute and running models simultaneously while you're doing the analysis. That can create a lot more benefits. But I guess the question is, if you're trying to do something new, to Guy's point, right, or use data that you don't otherwise typically use with that model, might you not need to rely back on something, on the back end? And if so, is there a place where you need sort of almost like the clutch pedal friction point between when you transition from my edge device to my cloud, my cloud capability when I need it?
Okay. I think that's a very good important point over here. But let me actually answer it in a way that, from a device perspective, what actually happens underneath.
Yeah.
Increasingly, it's clear that for any use case, it's not going to be one single AI model that's used at any given point in time. It's going to be a
Right.
mixture of models that is put together. And the way this works right now is, we just introduced something known as a AI agent orchestrator. Think of
Mm.
it as an agent that is sitting inside your device, and almost like as if, how can I help you? You're just asking a question for something, right? And what happens then is this orchestrator then decides which set of models to use at any given point in time. So you have like a bouquet of models which are resident inside your device. You pick a
Yeah.
few of those models because to answer that question appropriately, you're going to use those. Then you're going to tap into what is known as a personal knowledge graph. It's about what you have done over the last maybe 1 year or so and actually fetch some context from there,
Yeah.
and then process it all together and then provide the response. So it doesn't have to, the entire burden doesn't have to fall on a single model, but it's going to be like a mixture of models.
Yeah.
That being said, the same orchestrator at some point might decide, okay, this is a lot and I might need some help. In which case, you always have the option of just going back to the cloud and
Yeah.
saying, I need some additional input from there. I'll give you my first set of response to you, but then I will get some refined response that's
Right.
coming from the cloud as well. So this is how we see the trend lines coming up.
So, Guy, let's talk about this in the investment context and the business context. So, if you're using these sort of ensemble models that Dr. Malladi just talked about, and laid out for us, right? Is there an opportunity here, from an investor perspective, to think about, sort of combining these use cases, the approaches, right? The idea of edge compute on one side for AI, cloud compute on the other side, and sort of, making sure the connectors work, that they're secure, that they're protected. Because I mean, obviously, if you're out in the battlefield, right, you're going to want to do some stuff securely on your device. You're also going to may need to communicate, if you have comms back to the larger cloud computing capability. You're going to need those comms to take place securely, particularly if you're using sensitive data that you just captured on the battlefield in real time, right? As the adversary is nearby trying to capture as well. So how do you think about sort of security, in the context of this sort of cloud edge scenario?
By the way, you're also going to need to push all that localized data and computation back so that the centralized models get smarter in the long run too,
Right.
right?
And
Don't
the guy
forget
down the
about
street from
that,
you, the
right?
guy 10 miles down the
Right.
road has the same
So,
info you have.
so I don't, there's no question that there's sort of a hierarchy to the augmented decision making that will occur. I think
Yeah.
I, I think that's fairly obvious that we go down a path where you've got, as Dr. Malati talked about, a hybrid architecture of sorts, right? So I'm not. I'll give you an example of something maybe practical, even that we think about today. So, we made an investment a couple of years ago in a company called Overwatch Imaging, which
Mm.
is deploying edge-based image processing right onto sensors that are sitting on drones and aircraft, and it's able to do basically, I like to say the deployment of that technology changed the delivery. What most sensors, gimbals, multispectral cameras do when they're sitting on drones or aircraft is they pipe down video feeds to the ground, and that video gets processed and all this stuff. Well, what Overwatch allows you to do is it pipes down RSS feeds, lists of interesting things, rather than clogging up the airwaves and burdening the humans, where you have a linear relationship between the amount of soldiers or analysts that have to look at data versus the amount of sensors you put up in the sky. Now, you can think about how the identification of objects, this allows you to basically, in real time, at quite cheap loaded cost, identify both new objects on the ground that you've really never been aware of, to clarify what objects really are by sort of running things across multiple different types of sensors. The ability to understand, something looks like a tank, but it's probably not, because the heat signature says it's probably a decoy. And then the ability to then pump that back for something else, probably at the cloud level, to probably make context of what's going on. Right. So that Overwatch sensor is never going to be designed to try to figure out what operationally an enemy is doing on the battlefield. It's serving a task to reduce the cost and increase the speed of our ability to sort of understand the object layer. Right. So I just think in terms of, and then you have to just layer in, like, what's that worth? The other piece that's really important as an investor you've got to pay attention to is, okay, all these things generate value, by the way. All of these AI, they always generate value. They come at cost. Sometimes that value is not commensurate with the cost that you're paying for it. And sometimes it's not worth the noise. And obviously you get into security. So you asked me originally about security. I'm almost like least, at this point in time, I'm almost like least worried about the security of it.
Interesting.
I'm more worried about the practicality of it right now.
All right. Well, let's talk about that, Dr. Malladi. What's your sense of the practicality? Because it's my sense that because of the rate at which we're growing in terms of chip capacity and the ability to deploy these capabilities forward, I actually am sort of, confidence the wrong word, bullish on our ability to solve some of the problems that Guy's laid out about massive amounts of data, the need to sort of deal with them quickly. I actually think that these models have the ability to sort of help us with that. But tell me if that's right or wrong, and if that is right, what should we be concerned about as we think about this data staying forward and being processed forward instead of pushing it back to figure out what it means?
Yeah, I think what Guy actually mentioned, that there's a couple of things that are critical over there as I go into the actual use cases.
Yeah.
So if you just think about what is coming up right now, just in terms of the use cases, we have things like code generation is one of the examples that I gave, where in software industry, actually, it's a pretty big, I would almost call it as a lifesaver, in the sense that there's a lot of mundane work that is done as a part of
Yeah.
generating code, and software engineers like to work on algorithms in addition to actually debugging and so on. So just in terms of productivity tools like that, in addition to what I just mentioned earlier about document creation and summarization, translation, there's like massive amount of enterprise productivity increase that occurs. The key
Yeah.
question as you kind of go through this is, and this is something that we spend some time looking into, is what is the cost of doing that if you manage to, if you run all of this in a centralized cloud server versus distributing the processing into all the devices that you and I have? And it turns out that it is significantly more economical to actually run it on devices for these kinds of use cases. In other words, hey, I don't necessarily need to have connectivity to some deep cloud data center just to write a piece of code on my laptop, and I can actually do it already. So it's like simple things like that. So for a lot of the use cases, we believe that the cost is actually significantly smaller. In fact, I think it was in January of 2023 when there was a Reuters article. There was an interesting one that simply looked at, okay, picture the following. We all use search. So let's say that moving forwards, and that's actually happening, search is going to be increasingly powered by AI algorithms. And you're going to be running search in a data center. And say that every time I search for something, it's going to need processing in the deep cloud, and I get a response back which happens to be 10 words or 50 words or 100 words. So you have one variable which is the length of the response back, and then the
Right.
other variable is how many people simultaneously are searching at the same point in time. When you kind of take a look at both of these two put together and you start scaling out how much it costs to do this, it just happens to be like exponential just in terms of the growth, in
Yeah.
terms of the cost itself. And the real question is, do you want that to happen, or do you actually balance it out with the more energy efficient processes that are already in our devices today? Why not actually do it that way? So
Yeah.
from an ROI of use cases versus the cost of running inference, I believe that the edge actually wins out for the kinds
Yeah.
of use cases that we are thinking of today. There are some extremely sophisticated, massive use cases which are like way beyond what we are talking of. And yeah, that one can run in the deep cloud. But for a lot of these carpeted enterprises, creativity in terms of creation of, it's generating new content and so on, the device view is actually cleaner and simpler. And it's just the way that things have evolved. The processors and the devices are very sophisticated, and they also happen to be energy efficient.
Yeah, well, Guy, what about that? I mean, this, it reminds me of those old, graphics we used to see on government military slides, right? Where you'd have this distributed grid out in the field where all the devices are talking to one another. They're not necessarily having to report back home to a centralized device. But then, of course, you built capabilities where the thing that got the data to the warfighter the fastest was bringing a bunch of data back, processing fast, and kicking it back out. So there's a trade-off here, right? How do you? I mean, Dr. Malladi, not surprisingly, is making the case that like this is all going to happen. It's better, cheaper, faster. Do it locally. But I mean, what do you make of that for at least the operational national security context?
Well, again, this was, I think I provided a generally uh, somewhat simple frame in the,
Right,
in the prior conversation.
right,
Is this a problem that requires kind of global context or not?
yeah.
Right.
But a lot of these
So
military problems will require global context, right? I
well,
mean, like the one guy on the battlefield, right? It would be really helpful if you knew everything the big brain back at the Pentagon knows, right?
yeah, and maybe even you get to a point where you're sort of asking those questions in parallel, and in a
Yeah,
hybrid environment you're getting immediate knowledge from the device and you're doing some of that, and then you're able to augment um, from the cloud with additional information. And again, at one point you're pumping all that localized information back to the cloud
yeah.
so that the cloud is getting smarter in the long run, and those instances are getting smarter. But I just think it's dependent on problem sets. And
Well, but what
so,
about yeah, but Guy,
you know,
but what happens when you have to act now, right? And you do the processing
yeah.
locally, right? While you send it back for the parallel, parallel on the parallel path, and the parallel path comes back with an alternate answer, but you've already acted, right? I mean, that's I think what everyone's worried about, right? Like, hey, my device, my immediate decision making is here. Now, look, that actually replicates a problem that humans have
Well,
all the time,
that's what I was going to
right?
say. I mean, I always find it interesting when people, sort of dive into these edge cases as excuses for why the technology won't work because it'll
Right,
screw up human decision making.
right,
And you're like, we get screwed up all the
right.
time,
Human decision
every
making is
day,
terrible, right?
right? I mean, we ask somebody one thing, we start doing it, and then we ask somebody and we get different information. 2 minutes later, we realize that we have to make a decision. Do we reverse our decision because the information's changed a little bit? Do we come back to it? I mean, it's another source of knowledge,
Yeah,
and frankly speaking, smart humans, you're actually starting to make a case of why human judgment still matters,
yes,
right? Because
yes,
you're starting to make a case to realize that the smart users of AI are the ones not who know how to ask a question of a system, but they're the ones who appreciate the complex, sort of the complexity of it, and they appreciate the depth and breadth of what they sort of have access to,
Yeah.
and they're able to say, okay, I understand what I'm going to get back. I understand the risk and benefits of what's going to kind of come out of this particular question asking I'm going to do over here. And I'm going to make a judgment of whether I blindly follow that,
Right.
or I'm going to make a judgment of whether I figure out a little more, or whether I tread lightly,
Yeah.
whether I
Yeah.
go
And
all in, right?
that's right.
This is human judgment.
That's right, and that's exactly why I worry. I worry little about the hallucination problem because it's actually solvable with delivering an ounce of human judgment right on top of it, right? And I think that's really the benefit. So, Dr. Malladi, I know we're down to a limited amount of time, and I haven't even got through like an eighth of the questions I was going to ask you guys. But this has been such a great conversation because I think there's so much here to plumb into. Dr. Malladi, talk to us about what you're most excited about looking forward to the next 5-6 years, and maybe that's not even a fair metric because, as you point out, it's been 2 years since OpenAI hit the scene and sort of the public really sort of figured out what was going on and is now adopting at massive rates. But as you look at the next 2 to 3 years, what are you excited about in this sort of cloud edge forward processing space?
I think it's a couple of things that actually truly excite me, and yeah, we do have, the technology pace is going to be pretty fast. I mean, it's probably one of the fastest moving technologies that we know of, but at the same time, I think what's clear is the fact that there are some very large number of use cases that are going to improve productivity right now, even with what we have today. So the thing that actually excites me is bringing all of this together in a way that makes it easy for us, changing the way that we interface with devices like voice UI. I really want to get to a point where we showed a demo, by the way, last year, where without picking up your phone, there's a person who's just saying, we did this demo in Hawaii, and we just said, okay, I want to fly back from Maui to San Diego on Sunday sometime in the afternoon. That's it. That's all that you said, by the way. And if you're going to think about it, okay, then after that, immediately you get a response in like 2 seconds that says, okay, found a couple of flights for you. And by the way, I know that you have some status on United. So I looked at the United flights. These are the ones. Well, the price is a little too much. Can you change it to like over the next 3 days, find a different one which is a little lower, or find something else for you on Tuesday? Can you add three more people to it? My wife and my daughters. Yes, I can do that. And then done, without ever touching your phone, without ever actually using that. That is so powerful.
It's
And
wild.
and by the way, it is something that really fundamentally alters the way, and maybe in the process of all of this, we come out with like brand new kinds of devices as well. So just the raw potential of that, massively. It really excites me on that.
Yeah.
The
So,
other
Guy,
part,
I want to. Oh, sorry. No, please. No,
no,
Dr.
I just
Bloody,
want to say
please
that
keep
in
going.
addition to this
Yeah.
is like, okay, the user interface that we are talking of. The other part is, I think there are implications of generative AI. We talked about software and we talked about smartphones and so on,
Hmm.
but there's massive implications on other fields like medical field, for example. Think
Yeah.
of the following: every time you have like a lab report, or maybe you just got an ECG done or a physical done, you have the equivalent of a medical co-pilot, that already gives you like a first cut response. And as a doctor, you actually will have, you're going to be the final authority, but you do have this additional help that's coming in on the side. And maybe finally we'll take a stab in terms of how do we improve medical healthcare with this, because AI has some massive potential there.
Yeah.
There's tremendous amount of data. So this is the other part that really excites me, going into areas where for the longest period of time there hasn't been that much amount of digitization and usage of these techniques. I think the potential is huge.
Yeah. So, Guy, you get the last word here. And I want to get your thoughts on all on the kind of things that Dr. Malladi has talked about, and put us in the national security context. What are you most excited about as you look at as an investor at Squadra? You focus on dual use investments in the national security space. This is what you've done for a significant part of your career. Talk to us about what gets you most excited the next few years about the application of these capabilities in the national security context.
Yeah, so maybe I'll split it into three ways. One I would say is just I'm always excited about practically simple things that um, that sort of work at maybe what we think of more as the infrastructure level in this space. So, for example, we invested in a company called Falcom that builds low power amplifiers that augment edge-based capabilities by just making the signal amplification 30% more effective. That's going to have implications on phones and things. And
Sure.
so that's like simple thing, but I like it. Okay. Yeah. It's practical. It's ready to go now. Two, I like areas where we're solving a problem that's just all of a sudden now solvable. So for where the market's actually just been just a little bit too burdensome without the use of AI. So for example, hyperspectral imagery, where we've always for years we've had access to be able to run imagery across a broad set of frequency bands and to be able to produce 400 pixels where there's a pixel.
We just don't know what to do with it.
Who's looking at all that data?
Right.
So now we can, right? We just invested in a company called Wyvern, our first Canadian investment. And then the third one is, again, it just kind of goes back to everything. Anything that, for me, what's exciting though, is again, going back to this theme I talked about before, anything that helps move the national security environment from something that has been constrained like a service company, where we scale our capabilities with the amount of people we are willing to throw at the problem, to be able to start to behave like a product company. And if you just keep like the financial context at play there, it's like being able to go from, if we correlated like if we said, oh, the capabilities of our country's national security environment, we went from being a service company to a product company. We could go from somebody measured at 2 times revenue to 10 times revenue. If we could bring that kind of power to our military, to our national security community, I think that's what's exciting. And I'm basically looking for products and solutions that we feel are going to have a short to midterm impact to be able to move the ball down that lane. So that's what really excites me.
Well, what worries me about that context is, just as we're wrapping up, obviously it's hugely empowering for us and our allies, but it's also empowering to the smaller players who now can play like a large nation state, right? Because they have these product capabilities available to them that used to be they just couldn't do without the number of bodies, or the amount of money, or the amount of compute that we threw at the problem. So it worries me a little bit, but I think at the end of the day, you're right, because when you add that on top of a country like ours, or allies, you'd only empower them even more. And so I think at the end of the day, it works out fine. But I do worry a little bit about that, which is why I think it's so important that we sell and we work and ensure the technology focuses on allies and our friends, and make sure it stays out of the hands of our adversaries. All right, folks, that's a wrap. Thanks to both Dr. Durga Malladi from Qualcomm and Guy Filippelli from Squadra Ventures for joining us today. Thanks to Keelan Wolf and Claude Jennings and the entire NSI CTC staff for their help in producing today's episode. The Control F podcast, including our game-changing technology series, is also on YouTube. So be sure to check out our NSI's page on YouTube for a video of today's episode, and make sure to stay tuned in for the announcement of our second season, which will start early next year. And always, if you like what you heard, saw, or checked out in the combination of audio and video on YouTube, be sure to rate, review, and subscribe.